Okay. Hi, welcome to the second, actually, this is the third programming workshop thing. So essentially, last time we went over the robot code and we looked at the structure of it. We delved into the role of subsystems and commands, and we just looked at this like structure that we use for organizing all of our Java code. This time we're going to go a little bit deeper, and we'll try to like understand fundamentally like how these classes work, as well as like answer any questions that might have been like, created by last time's session. Okay, so cool. So the first thing I think that we should look at is just a quick recap of like how subsystems and commands work with each other. So like, as we discussed last time, a subsystem is essentially an implementation of a hardware specific thing in code. So for example, in our subsystems, we might have something that corresponds to the drive base. And in the drive base, we're defining certain characteristics such as certain motors. And we also provide some code that sets the, like how these motors are supposed to function. Essentially, we're declaring like hardware specific stuff. We're saying, well, there's supposed to be a motor here, and this is how you access it. And you also provide methods that allow you to set raw values to these hardware things. So aside from drive base, another thing might be like, for example, the intake. So in last year's robot, we had to have an intake for how we were going to pick up things like power cells. Those were like small yellow balls. So for this one, again, we're defining hardware. We're saying that there is supposed to be a motor here, and we also define the default functionality, and we also provide a method that sets a raw value to that motor. Same thing with the shooter. Again, we just used another motor for the shooter. Let's see. So color sensor. Here, the color sensor is unique. It's not like a motor or anything because it plugs directly onto the RoboRio through a thing called the I2C port. So here what we're doing is that we're creating an object that represents the color sensor using some Rev Robotics libraries. And again, this is fundamentally the same idea. We're creating a hardware like we're implementing the hardware in the code, and we're like allowing access to it through like these basic methods, if that makes sense. So we're defining that hardware thing, and we're also like providing a method which represents the task that we were like intending the color sensor to be used for, which was to detect the presence of a ball. So subsystems fundamentally are providing like these interfaces to the actual hardware. And the way that we define what happens with these interfaces is through commands. So last time we went over stuff like the vomit command. Essentially, if we had some balls in the index inside our robot, our vomit command would just be used to spit them back out. Here, we're saying that the vomit command depends on the color system subsystem. It depends on the intake subsystem, and it also depends on the index subsystem. And the commands here are just specifying what should happen every 40 milliseconds. So when this command is activated, we want the index subsystem to execute this method every 40 milliseconds. We want it to continuously run the motor at a value of minus 0.5. And same thing with the index as well, with a value of negative 0.8. So these are methods that were defined in the subsystem. Again, subsystems are providing access to the hardware. The commands are utilizing that access that we created in order to actually make the robot, to make the hardware do something. Samrat, do you have anything to add?
Yeah, no. One thing I would note is the end method, and that is for like when your command is finished running, you want to make sure that you are actually like setting those values equal to 0. Else, if you like start running another command, it'll like continue using those values and therefore it won't actually stop. And you just so in the end method, you actually have to like manually like set the values equal to 0.
Yeah, it'll keep running unless you set it back to 0. So, so again, with commands, as we discussed last time, it's possible to set these sorts of timeouts. So for example, index and shoot, actually, this is not the right one. I meant shooting auto, I believe. Yeah, you can set these sorts of timeouts. So here, this was a command called shooting auto, and this was where on the driver, on like the this driver station dashboard, you selected that you selected an autonomous where you would want the robot to actually shoot into the target. So we're saying that this command requires the robot drive base, and we're calling these other commands, and we're setting timeouts. So this is a timeout of 3 seconds. We want the distance alignment command to run for 3 seconds. We want the rotation alignment command to run for 2 seconds, and so on. This allows us to set a sequence of commands. And it's like the idea of modularization, because we don't want all of them to run at once. Obviously, they can't. But we want one step to be executed before another. For example, the robot needs to be aligned with the target before it can shoot, so the balls actually go into the target. All right, so Samrat, you have anything to add about that?
No, I mean, like once again, Anand said, like there's modularization. In that example, that we were using what we call sequential commands. The other type of command, or like I guess those are part of command groups, and for like sequential commands, basically what it does is that it runs one command after another. There's also another type of command, or like I guess like function that you can use, and those are called parallel commands. And so what parallel commands allow you to do is run like multiple commands at the same time.
All right, so the next thing that I want to go over is just the OI class. So again, the OI class is where we define all of the inputs to our robot. So here we're creating an object that represents the joystick. We're also creating objects that represent buttons on the button board. Actually, that's down here. Then what we can also do in the OI class is define certain actions to be executed when certain buttons are pressed. And as you might guess, these actions are actually commands. So for example, let's say when the A button is pressed, we want to switch drive modes. So last year we had 2 separate drive modes. One was like, so one's called tank drive and the other one is called arcade drive. It's different methods of driving. So I'm just going to provide a brief overview. So on tank drive, you know how on an Xbox controller, you have 2 joysticks? Those directly control what the sides do. So on the left, if you were to push up, and on the right, you were supposed to push down, then the robot would start turning clockwise. It's a little hard to envision, but just know that it's different. Like tank mode and drive mode require like different, the inputs are just different. In arcade drive, the left joystick is used for robot front and back, and the right joystick is used for turning left and right. So we wanted a method to be able to switch from one drive mode to another. And that's why we said when the A button is pressed, we want to switch the drive mode.
Wait, Anand, I just want to correct you real quick. So we did not implement 2 like drive modes, I guess. We didn't implement tank drive. We only used arcade drive. But what we did for the drive mode thing is we had a slow mode and a fast mode. The fast mode was like almost uncontrollable. And so we had like a way to switch between like going like a slower like mode versus a faster mode. The slower mode would allow us to actually control our robot versus a faster mode that would just like allow us to like get to the other side of the field very quickly.
Oh yeah, I'm sorry. Okay, so the tank drive and the arcade drive thing I think was from 2018. So you can see actually Samrat is right. So if we go to oi.java, we're executing the drive mode command when the A button is pressed. So we're defining that here. And this is a special type of command called an instant command. So all of the commands that we've looked at in the past have certain sets of methods like the when finished, if finished, those commands that tell it when the command is finished. Those commands are like, it runs every 40 milliseconds until it's stopped explicitly and another command takes its place. Instant commands just run for one cycle and they do one thing. So in this case, when we press the A button, the drive mode command runs, and all it calls is just arcade drive.change drive mode. And we define that here, arcade drive is a command. So in the drive mode command, what we do is that we have a certain variable that represents the drive mode. It's the speed. So here 0.4 represents slow mode and 0.8 represents fast mode. In change drive mode, if the drive mode is currently at 0.4, that means it's like the robot is going slow. We want to make it fast. So then we define, and then we set drive mode to be equal to 0.8. If not, if the drive mode's already at 0.8, then we want to set it to 0.4 to make it go slow. And that's sort of like the toggle that we used for switching between slow mode and fast mode. And that kind of represents how this OI class works and how we're like assigning certain actions to certain buttons. Cool.
Oh yeah, go ahead.
No, you go ahead.
Do you think it would be worth looking at 2019 code for the pneumatics and stuff like that?
I think we should. Before we look into that specifically, does anybody have any questions? Any questions? Yes? No? If you don't have questions, just at least say no. Come on, guys.
Okay, question.
Yes.
Why are there very few comments? Readability, come on, my dude.
Okay, we literally have like, look at this comment, okay? We literally have climb, okay? And then we have another, like, okay.
Wow.
Big brain.
I mean, okay, yeah, so for like some of the files that we like had earlier on, we were
Okay,
adding
that one has more.
Yeah. So for like some of the files that we wrote like earlier in season, we had more comments just because we had time. A lot of this was written like late season and we didn't have time. We were just trying to rush through, write as much code as possible. So yeah.
Yeah, I'm gonna be honest. Yeah, it was most of this code was written in the last 2 weeks.
Definitely, yeah.
All right, so that's that. So we want to look at the 2018-2019 code for pneumatics. We can. I'm just not sure how well I know it, to be honest.
Okay, same. It's because Sahil is a bunch of booleans instead of just command groups.
Yeah. Okay. Let's see.
It's a 7-inch, I think. A 7-inch, yeah.
Who named that? Okay.
Oh, okay. Never mind. Maybe it's not a 7-inch. Oh, okay. Wait. Okay, yeah. So you have to go to the compress system and then.
Okay, yeah. So that's an instant command. Wait, he actually used instant commands? Oh, that's surprising. Okay. All right. So here we're defining a command. It requires the compress system subsystem. What we're doing here is that every 40 milliseconds, if no idea what that does. If that evaluates to true, we keep the compressing system on.
Okay, yeah. Now, how about we go to the actual like subsystem? I think that's where the bulk of it's written.
Actually, okay. Let's see. Oh yeah. Okay. Again, subsystems are like supposed to be implementations of hardware. So, wait, what the heck are solenoids?
Okay, so yeah, solenoids are those like pistons, I think. And so basically, with solenoids, it's like all it is. It's going to be like a true or false value. True is extended, false is like not extended, I guess. And so that's essentially the gist of it. So at the beginning, when he initializes all the subsystems. So okay, yeah. So one of the solenoids is for like the actual clapper. So we had a clapper mechanism on our robot, and so it'd go like this way. And so when you're actually starting, that would like start like this. And so solenoid 0 represents like the clapper solenoid, and so that one would be like, I guess, like closed. And then solenoid 1 represents so like we had this like, I guess, like mini elevator mechanism that would cause our robot to like thrust forward another subsystem. And so at the beginning of each like at the beginning of each match, we would have to set that to true, because like usually like our robot can't have anything like dangling off of it, right? And so we would have to keep that like within our robot, and then like after the match starts, we would have to set that to true until it would go forward and actually do its like mechanisms. And so in the like initialization, our solenoid 0 would be the clapper, and then our solenoid 1 would be the actual mechanism that causes like the subsystem like go forward and actually be able to like perform tasks. there's a compress on. I'm not sure what it does, simply because I've never used or I wasn't too heavily involved in like the pneumatic systems in 2019. Um, and then
I think what that's doing is just making sure that the thing is like always on. Not sure, but I think that's what it's doing.
yeah, or it could be to like use like it could be to like store pressure maybe, or I guess air. Like I don't really know how it works, but remember our robot was like really loud.
Oh, true.
Yeah, it was really loud when we were like I guess like gathering air or something. I think that's what it might be.
Okay, well, anyways, so moving on to the 7 inches method. So as Sahil has helpfully documented, it opens and closes the pneumatic piston. Yeah, so piston bool is apparently so it's storing the state of the piston as true or false values. Okay, yeah, and we're just setting solenoids equal to true or false, and I think that represent and that I think does it move the solenoid specifically or?
Yeah, I mean, yeah, I'm pretty sure so like I said before, where like the solenoid's either like true, which is extended, or false, which is like retracted. So this one just I guess like it moves the solenoid, if that makes
Pretty
sense.
cool. Yes.
Yeah, and then so the method called high gear movement, I think I don't quite remember how it works, but like basically our robot last year or like 2 years ago could like change gears. And so it used solenoids for that as well. Or like it used solenoid gears, I guess. I'm not completely sure what those are, but because I'm not too like mechanical, but yeah, basically you could like change gears with the high gear movement. And then yeah, the clapper movement, like I was saying, I was like, it's this, right? So there's like two states to it. And I'm not sure what the solenoid clapper. Okay, yeah. So it's setting the solenoid clapper to the opposite of like its current state. So for example, if the clapper is true right now, it would set it to false because like it says not solenoid clapper, so it'd go this way. If that makes sense. I don't know if that makes sense. Do you guys have any questions about that?
Where is it saying where is it talking about the solenoid clapper?
It's at the very bottom. So there's two methods. There's high gear movement and clapper movement. They do like basically the same thing, but yeah. Well, they do the same thing, but like with different solenoids.
Okay. Oh, is the exclamation a not?
Yeah, not yeah.
Okay.
All right, cool. Is there anything else worth exploring in your Anand?
Oh, bro, I was on mute. Okay. Yeah, so it's just setting it to the opposite of its current value. So if it's closed, if it was closed, now it's open. If it was open, now it's closed every time you run this. Let's see. I legitimately don't think so. Doesn't look like there was a lot of stuff, to be honest.
No, I'm pretty sure. Wait, check.
Fix
Yeah.
Sujer's millions of errors.
Wait, check the branches. I'm kind of curious if there's any other branches that are worth exploring.
All of them should be updated, to be honest.
Okay, never mind. No, okay, yeah, there's nothing worth exploring there. Wait, we had a tank track?
What is this?
Oh yeah, we did.
Ishan is my name? What? That's just weird.
No, I think. No, I don't remember why I wrote that.
Okay, actually, let's look at this. Hold on. Formatting, documentation. Post faulty works, changes. License updated readme.
Wait. Just out of curiosity, do y'all know how to use version control or like GitHub or a similar tool?
Nope.
Not really.
Oh, okay. And
It's fine.
Do we want to do that in the future as like one of our workshops?
Yeah, we'll teach y'all. It's a very helpful skill to have.
Yeah, definitely.
Add a command that almost runs into a wall connected to button B. Thank you, Sujay.
Wow.
All right. Cool.
Add in
Probably.
comments to make a non feel bad? What Sabra? What the heck?
These are some great names.
Bruh. Wow. I wonder what else you'd put in here. Can't believe you did this. Can't believe you've done this.
Is GitHub and Version Connect, is that basically just like a directory of it?
Bruh, what is this? Okay, I'm sorry.
Wait. Can you repeat that again?
Is Version Connect and GitHub, are they more of directories and like where you put everything instead of
Version
what
control.
version control?
Yeah. So GitHub's like a type of version control, basically, and you can kind of think of it like you can kind of think of it as like Google Docs for code. It's not exactly Google Docs for code, but it's very similar. Basically, it allows you to like collaborate on like pieces of code, essentially.
Okay.
Yeah, so version control. So it allows multiple people to collaborate. And so like if we're both working on like the same file at the same time, when we push it to GitHub will like tell us that there's something wrong. Typically, if we were just developing code on our computers, then like, you know, it would be difficult to share the code. We'd probably use something like a USB drive to carry it over. And then if we were working on the same file at the same time, how would we like resolve the differences in the files? So version control makes that easy. And it also gives us like the exact history of like who made what and what changes. Like, look at this. So like me on January 17th, 2019, like I can probably find the exact time as well, but I added these lines and I changed these things. So it tells me like exactly what I added and removed. So it's really good for like debugging. So yeah,
Okay.
that's why we use version control. GitHub is just the version control. Git is the version control that we use, and GitHub is the platform where they host that Git for us.
Okay.
Bro, but like, what is this commit? Okay, like Samra, I couldn't believe you'd do this. I thought we were such good friends. Bruh. Okay. All right. Is there anything else that we want to look in our 2019 code? Samrat, you're on mute. Samrat, we can't hear you.
Wait, sorry. Okay, there you go. You can hear me now, right?
Yeah.
Oh yeah. Do you want to go over like the Gradle files? I don't know if it's worth going over.
Not really.
Okay, yeah, okay.
So, okay, I think maybe we should.
Okay,
So,
yeah, sure.
Gradle is just the way that our build system works. So like we have to write code in Java, right? But so Java typically compiles into files called class files, which are translated code. And that's what actually gets uploaded into our robot. And then the RoboRio is able to understand .class files. That's why if you go here, you know, there's a bunch of .class files. So each .java file has a separate class file that it compiles into. And we upload those class files into the RoboRio and they execute. Now Gradle is the way that we automate that uploading and like compiling. And Gradle also lets us know if there's any issues with compiling, and it's like tuned for FRC. Yeah, honestly, it's pretty difficult to upload files to the RoboRio manually because, you know, you have to connect to it over the internet using some like command line Linux stuff, and then you have to like manually upload each file, but Gradle just connects to it automatically, uploads everything, gets out. So
Okay, wait.
yeah.
I'm gonna join the Zoom meeting on my other laptop. Just so I can like so I can show like y'all like what the driver station all like looks like. Yeah, because like y'all saw pictures of it, but I think it's a lot nicer if you can just like see the program itself.
Okay. Are you sure that the meeting just like won't end?
It shouldn't, because I don't think I'm logged into Zoom on this laptop.
What if the recording ends?
I
Okay, cool. Is it recording? All right, let's go. So this is Gitkraken, and this is like this is a GUI alternative to like command line Git. I just wanted to show you guys this because it shows like I guess like the power, I don't know, of version control. So you have like these things called branches, and people can be working on like different branches. So like here, this was Samra, and he was working on the buns branch. But then at the same time, Samra was also working on the autonomous branch. And when like people are done with the branch, they can merge it back into the master branch. And like these merges can they like stack on top of each other in things that are known as commits, if that makes sense. So like particularly like here, let's see. So Samra like forked this particular branch called I don't even know, like this red branch from the master branch at this commit, and like Yash added some stuff, I added some stuff, but then Samra was just able to merge it back in with no difficulties. And the only reason that happened, that was able to happen, was because like version control handled the code differences for us automatically, if that makes sense. So it isn't just like two branches and like it automatically figuring it out. It's like juggling like so many branches. Like, so right here, we have 1, 2, 3, 4, 5, 6 concurrent branches that are all being merged back and forth into each other. So that's why Git is really nice, because it just allows us to like organize our code. Otherwise, it would just be like copy pasting between people's laptops.
All right. Yes, I have logged in now. If you want to stop sharing your screen. Cool.
Yes.
All right. Wait. Okay. All right. Cool. All right. So, okay. Wait. What are we gonna start with? We can start with the driver station. I don't know where it is. I have too many apps on my desktop. All right. Cool. All right. Yes. So this is like the thing that Anant was showing y'all. Oh. Yes, this is the thing that Anant was showing y'all at that first workshop. So like this is like, I guess, like the driving tab. There's different modes that you can go through. So there's like teleop, autonomous, practice, and test. And then like here you can like enable the robot. I'm not connected to a robot, so it's gonna like flash over here. And then yeah, so that's like that. You can also like check like, I guess, like your signal strengths and everything. See if everything's okay. I think that's also like power. Yeah, volts. Oh, this is like lagging. Sorry.
I can't see anything.
Wait, can y'all see? Can y'all see stuff? Anant, can you see something?
Yep, I can see stuff.
All of the videos seem to have cut for me.
Yikes. Here, can you leave the breakout room and then we'll add you back in?
Okay.
All right, can we add him back in?
Yeah, 1 sec. Let's see. Breakout rooms. Wait, oh. He's still in the room, I think. What? That's so weird. Oh wait, he should just be able to join back.
No, I think we have to add him.
Well, you know, if you leave a breakout room, you can join back. Yeah, so I'm using Smart Dashboard, and so here, like, so okay, yeah, so we have two interfaces, basically, or like two like boxes here, and these boxes are for like okay, so those are like show like the cameras basically, and so so yeah, so we had one camera for like the driving, and then one camera for the balls. We didn't get to implement the second camera, but basically like this like right camera here would show like the driver's point of view, and then the second camera would show like our intake system point of view. And so on the left you'll see some of these like statistics, and so the distance is like the distance away from it's the distance away like from the target, like our robot is. The target area is the amount. And on do you remember what target area is? I always forget this one.
So on the Limelight, you know how our Limelight gives a video feed? It also identifies the target and gives a bounding rectangle on that target. So it's the percentage that the small like area is of the larger image.
Cool, yeah. And then the skew amount is basically like I guess like how many degrees we're off from the target. And then the pipeline is, so there's different pipelines on the Limelight. And so like what pipelines allow us to do is they allow us to like set certain settings. And by doing this, we're able to like optimize our Limelight to find the target. And so we just set like what settings we want. Let's see. So yeah, so there's like, this is just more like Limelight info. There's like LED state, horizontal offset, whether we're connected or not, and then the vertical offset. All right, and then beyond this, we have like our USB oh yeah, so like if we connect something to this like laptop via USB, it'll come up. So for example, if we are to connect like our controller, for example, it would show up right here, and basically from here we can like set like we can see like what numbers are associated to like the USB controller. And so if y'all remember in robotmap.java, we had a bunch of constants basically, and those numbers come from here. And that's for like controllers and like button boards. For motors, we use a different type of software. I've never used this, so like I can't really say much, but I think it just gives like statistics about like I guess our motors or robot. Cool, that's the driver station. Let's see. Yeah, so radio.
Radio like configurator.
Yeah. So this is the radio configuration. There's actually like a lot of steps you have to do. This makes it seem very simple, but it's not this simple. There's like a billion steps. There's like documentation if you actually find it. If you actually like look through the FRC website, you can find like detailed documentation on how to set up your radio. But when you're configuring, you would be using this software basically, and it's been a while since I've done it, so I don't quite remember everything on here. But this is like just the software you would use. Oh yes, Phoenix tuner, right? So here basically this is where you can like, I believe you can like update the firmware on your robot here, and then or that might be another piece of software, but here you can also access like your motors. And so if you remember in robotmap.java, we gave our controller values some values, and then we also gave like our robot motor some values. And so our controller values would be in the actual driver station. For the motors, we would have to do it through here. And so if we go to like CAN devices, I am so sorry. Yes, there we go. If we go to CAN devices, when we're connected to the robot, you'll be able to see all our motors. And then this ID section is the actual values that you would be assigning to the to those motors. Is there anything else, Anand? I think that's it, right?
Yeah, I think so too. We covered most of this. It's nice to look at it in person though, so I think that's it.
There's also the imaging tool. I think you use this to update your firmware. Yeah. So yeah, you can update the RoboRio firmware basically every year. Every year first releases like a new piece of firmware for your robot, and then you just use this to like update your RoboRio. Cool. I think that's it. All right. Are there any questions regarding any of that?
I had a question, but I just lost it as I was going to ask it.
All right, that's fine. If you think of it again, you can let us know.
All right, I'll message it to you.
Cool. All right, I'm gonna go ahead and stop this recording.